Hi friends, this is Sarojin here. Welcome to my networking channel. Hope all are doing good. And today let us discuss about the load balancing issues. There are two types of load balancing. One is an equal cost and an unequal cost load balancing. So here I am going to show about the unequal load balancing, unequal cost load balancing. So for R1, for reaching this R3, as per this architecture, for reaching this R3, so R3 I define the network 3.3.3. This is a loopback address I define. So for R1, for reaching this prefix, right? There are three paths it will take, right? One is R1 to R2 and R1 to R3 and R1 to R4 to R3. So each and every path I assigned a different bandwidth. This I want to show an unequal cost load balancing. This is 5120, this I have assigned, and this I have assigned as 1280. So how it does unequal load balancing is done by means of parameter called variance. So that is a parameter always that variance value you have to properly assign. Otherwise it will not do the proper unequal load balancing, right? So let us see today how it will do. So here this is the bandwidth I was in 5120 and this is 1280. So now let us go to the topology. So let us go to R1. So EIGRP already know that it will build three tables, right? One is a neighbor table. So neighbor table, what it does, it will capture all the neighbor information and it will store in the neighbor table. And topology table, it contains all the entire network information you will have in its topology database. So EIGRP, another special feature is elect successor and the feasible successor. So you can see all the information in the topology table. Let us go to the topology table. Show IP EIGRP topology. So topology table shows always a successor and the feasible. So here it is showing one successor and FD. So what is an FD and AD, right? So before going to troubleshooting, let us understand what is an AD and FD. So AD is an advertised distance. So if this is a prefix, it will advertise a specific distance, what we call it as an advertised distance. And the total distance, right, R1 to R2 and R2 to R3, this total distance is calculated as a feasible distance. So in the topology table, it will show FD by AD, right? So this is the thing it will show. FD is 43520. This is an FD, and this is an AD is an advertised distance. You should not confuse between AD is an administrative distance also there. In case of topology table, we call it as an advertised distance, right? So this is an FD is a feasible distance, and this is an advertised distance, and this is the interface it via reaching. So for reaching 3.3.3 prefix, there are three paths it is showing, right? R1 to R2, R1 to R3, and these are the path it is showing. Let us see. So let us go to R1. You are able to see, right? We'll take only this prefix, 3.3 prefix. It is saying 1.2, 3.2, and 2.2. You are able to see, right? 1.2, 1.2 is this prefix, 1.2 and 2.2 and 3.2. These are the three paths it is taking. That three paths we are able to see in the EIGRP topology table. So topology table will have successor and all this information. It will show whether the route is passive. Passive is nothing but always the route status is good. Successor is always the best route is a successor. So that topology table will have all the information like successor, feasible successor and everything. And but the routing table it contain only the best route information. That is the successor. Let us see. Show IP route. So routing information contain only the, so in topology table, that is the only difference. So topology table is showing all the three paths, but in the routing table, you are only seeing the two path. Why? Because it will always push the best route into the routing table. That is the reason it is showing only the two best path into the routing table, right? So these are the best path. First is an IAD. AD is an administrative distance, and this is a FD. Least FD will be placed in the routing table always. But due to the unequal load balancing, I have configured the parameter variance. So due to that the unequal cost balancing, it is showing the two path. That you always keep it in mind. If I'm removing the keyword variance, it will not show the two different path, right? So the variance parameter matters. So variance 1 is for equal load cost balancing. So here define the parameters as variance 3. That is the reason it is showing two equal path, right? So two unequal path it is showing. So variance is for 1 is for equal cost balancing and 2 to 128 for unequal load balancing. So here it is showing only the two paths. So why? Because of the variance parameter. So we have to change the value. How we can do that? I'm going to show it. So go to show IP EIGRP topology. So take the least feasible distance. This is the least feasible distance and multiply by the parameter. So into 3 if you are doing, it will not come 21, right? So always it should come 4 into 5, it will come at least approximately 21, right? If you are doing the calculator, we can check it out. So if you are doing 435200, 435200 into 5, it will come approximately this value, right? 27676, something like that. The same value it will give. So always you have to increase the variance parameter value. In case if it is not doing the it is showing only the two path in the specific routing table, right? You are able to see only this in the two paths, right? For reaching 3.3 dot prefix, it is showing only two paths. So what we can do, we can increase the value. Let us go to the configuration mode and router EIGRP 100, and I remove the keyword show variance 3. Instead, let us make it as variance 6. We'll make it as 6. So now let us check. So now you can see it will show three paths. Previously you are seeing only the two paths. So now let us check it out. So this is the magic. You are able to see, right? With only the variance parameter matters. So after increasing the variance value, now it is load balancing, unequal load balancing is done by means of three equal path, right? So for reaching 3.3 dot prefix, it can reach via R2 or R3 or R4. Thus, that is a benefit of unequal load balancing. And this is the way we can debug the variance issue. So always such a type of questions you can also come across in the unit networking, CCNA exam or any other exam. So always you have to check for the variance parameter. You have to check for the variance value. If it is less, you can increase the value. So this is the way you can troubleshoot the issues. And what are the configuration I have done is, so it is simple configuration I have done. I have configured EIGRP 100 and I have specified the individual network. That's the way I have configured here. So only additional things I have configured is I have configured where the variance parameter keyword in this R1. So remaining things I have configured the directly connected interfaces. If you want, let us go to R2. Show run. So include EIGRP 100 I have configured, and then I advertise the directly connector interfaces with the network command. So these are the network I have defined for each and every router. So that is the only thing I have done, and this I have assigned the bandwidth keyword. So let us go to R1. So let us go to R1 and show run interface fast Ethernet 1 by 0. So this I have set the bandwidth as 5120, and this I have set the bandwidth as 1280. So you can set the command as 51280, right? So the command is bandwidth 5120, and another one is 0 by 0, I guess. Yeah. Another one is 0 by 0. Bandwidth is 1280. So this is main purpose is to show the unequal load balancing, and always don't forget about the parameter variance. Otherwise, you can also increase the value to load balance across the multiple paths. So that is the advantage of unequal cost load balancing. So I hope you enjoy this video. Thanks for watching. Please subscribe me for more videos. Thank you and have a wonderful day.